Graphing logarithmic functions. Graph f of x equals 1/6 to the x power and g of x equals log base 1/6 of x in the same rectangular coordinate system. Here we have two inverses. F of x is an inverse of g of x and vice versa. In order to graph log base 1/6 of x, we're going to first graph the exponential form and then interchange the xy ordered pairs to graph the logarithmic form. I set up a chart and I picked values for x that were negative and positive. So I picked -2, -1, 0, 1, and 2. You can pick any values for x that you would like, but make sure that you pick negative and positive values. Next, we're going to evaluate f of x at each of these given x values. First, I want to find f of -2. That becomes 1/6 to the -2 power. This is a negative exponent, so I just flip the fraction, and I get 6 over 1 squared, which is the same as 6 squared, which is 36. So my ordered pair is -2, 36. Now we'll find f of -1. That's 1/6 to the -1 power. I'll flip the fraction because I have a negative exponent. So that gives me 6 to the +1 power, which equals 6. So my ordered pair is -1, 6. Now we'll find f of 0. That is 1/6 to the 0 power. Anything raised to the 0 power is 1. So my ordered pair is 0, 1. F of 1 gives me 1/6 to the first power, which is just 1/6. So I have an ordered pair of 1 and 1/6. And then f of 2 is 1/6 raised to the second power, which is 1 squared over 6 squared, and that gives me 1 over 36. So the ordered pair is 2 and 1/36. Now I just found all of the ordered pairs for f of x. Now I'm going to find the ordered pairs on the graph of g of x. And to do that, since g of x is an inverse of f of x, all I do is interchange the xy ordered pairs. So the g of x ordered pairs are going to be in the form yx. So all I'm going to do is switch these two values. So I had 36, -2, now I have 6, -1, then 1, 0, 1/6, 1, and 1/36, 2. Now I'm asked to choose the correct graph. So I have 4 graphs here, and I have the ordered pairs of f of x, which is the exponential function, and g of x, which is the logarithmic function. And I'm going to plot each of these ordered pairs on the graph and select the graph that is correct. Now, first, noticed that my first set of ordered pairs, the -2, 36, I cannot graph those on the graphs that are given to me because the graph doesn't go up to 36. So I'm just going to not look at those. Now we'll look at the -1, 6. And this graph counts by 2, so -1, 6 is about right here. So graph A has that. Now if I look at the inverse of that, 6, -1, that would be around here. And that value is not on the graph, so I know choice A is not correct. The same with graph B. 6, -1 is not on that graph, so B is not correct. Now with C, -1, 6 is not on the graph, so I know that that is not correct. So choice D is going to be my answer. And if we look at choice D, we can see that all of the ordered pairs that we found previously are on both of those graphs, the blue graph and the purple graph. And the blue graph in this case represents the function f of x, and the purple graph is g of x. Find the domain of the following logarithmic function. To do that, we're going to take the expression within the logarithmic function, and that is x minus 14 squared. Next, we're going to set it greater to 0, and that's because we cannot take the log of 0 and we cannot take the log of a value less than 0. So anything that is within the log has to be greater than 0. Now we'll solve for x. So I need to take the square root of both sides, and I get x minus 14 is greater than 0. Lastly, we need to add 14 to both sides. So I get x is greater than 14. So x has to be greater than 14. Since this is a polynomial inequality, then I have to create two intervals on a number line and then have test intervals to make sure that both of those intervals will work within this inequality, which is x minus 14 squared is greater than 0. That's the inequality that I'm checking. So if I look at my number line, I plotted 14, and notice that I have an open circle. That means that 14 is not going to be included in the set because it has to be greater than 14. My first interval is negative infinity to 14, and my second interval is 14 to positive infinity. For the first interval, I'm going to choose x equals 0 to test. And then for my second interval, I'm going to choose x equals 15 to check. When I check x equals 0, I get 196 is greater than 0. And that is a true statement, so I know that this interval is included in my answer. Next, I'm going to check x equals 15. When I plug that into my inequality, I get 1 is greater than 0. And that is also a true statement, so I know that this interval is also included. Since both intervals are included, but 14 is not included, I have the answer of negative infinity to 14 union, and 14 to positive infinity. And that is my final answer.